So we're going to talk about what partial fraction decomposition is. So this is a really useful technique for rational integrands, so fraction integrands, where the degree of the denominator is greater than the degree of the numerator. If the numerator has a higher power, that indicates that you should use division first. Another thing that has to be true for this to work is you have to be able to factor the denominator, and there are three separate cases for partial fractions. So case one is the simplest, and we're going to do that first. So case one is that the denominator factors two distinct linear factors. So distinct just means different or unique. So all of the factors are different. And right, linear just means that the only power of x in the factors is x to the first. So I'm going to write out my steps while I do this. So your first step is going to be to factor the denominator. So I'm going to do that just inside my integral. So I'm going to make this the integral of 1 over x plus 7 times x minus 1 dx. Okay. So what we're going to do next is we're going to set the fraction equal to the sum of the linear terms. So what I mean by that is I'm going to take my integrand. I'm just going to copy and paste here because I can. So we're going to take our integrand, and what we're going to do is we're going to split the denominator up to be the sum of two smaller fractions. So we're going to put the x plus 7 in one and the x minus 1 in another. And our goal is we need to figure out what coefficient should go in the top. So I'm going to put an a and a b. So once we do this, we're going to create a common denominator. So to do that, I'm going to still have this over here, and the common denominator is just going to be the denominator of the integrand. So what I'm going to have to do, right, is multiply each of these fractions. It's a weird A, but we're going to go with it, by whatever factor they're missing. So my first fraction with the a in the top is missing the x minus 1. You kind of think of this as cross multiplying on the right hand side, and the b1 is missing the x plus 7. So once we do that, we're going to solve the equation that's left in the numerator. So if all of the fractions have the same denominators, you can cancel them out and ignore them. So we're going to get that 1 is equal to a times x minus 1 plus b times x plus 7. So the easiest way to solve this is actually to use some simple substitution. So the first thing I'm going to do is I'm going to do this in green. We're going to let x equal 1 first. So if x is 1, the left side of my equation is still 1, and then I get a times 1 minus 1 plus b times 1 plus 7. So the a term is going to cancel out because it's going to be a times 0, and we're going to get 1 is equal to 8b. So 1/8 is equal to b. And then if I do this again, I want to now cancel out the b term. So we're going to let x equal negative 7. So that's going to give me 1 is equal to a times negative 7 minus 1 plus b times negative 7 plus 7. So now the b term is going to cancel out because you're going to do b times 0. And we get 1 is equal to negative 8a. So negative 1/8 is equal to a. So if we do this, I'm going to go back up here. A we just got was negative 1/8. And b was positive 1/8. So what this over here is called is the partial fraction decomposition. And it's because we decomposed, we broke a bigger fraction down into two smaller or partial fractions. And we're going to use this to integrate. So what I'm going to do is I'm going to take this stuff right here, and I'm going to put that inside my integral. And I'm going to add my dx at the end. So now these are technically u substitution problems, so you should technically split them up. But, right, we're going to be smart about this. We have linear terms in the bottom, and they have a coefficient of 1 in front of the x. So for instance, like just to do this real quick, if I made u equal to x plus 7, my du would just be dx. So I would end up with negative 1 over 8 du over u inside of this integral. So that's going to end up being the natural log. So if we work out like that, right, it's going to be negative 1/8 times the natural log of the bottom. We can just go ahead and do that because the derivative of the bottom is 1, so we don't really have to worry about anything. It's going to work the same way in the second part. So they're going to get plus 1/8 times the natural log of x minus 1. When you're doing partial fractions, you're going to end up with a lot of natural log portions. And then we're going to add on our constant, right, our plus c. So now we can also make this a little bit better if we think back to our algebra skills and our logarithm properties. So what I'm going to do first is I'm going to switch the order so that the minus 1/8 term comes second. Now if you're good with your log properties, you don't really have to do this part. But I'm going to do each step. I'm going to factor out the 1/8 from my two natural logs. And I can do that because they have the same number in front of them. If they were different numbers, we wouldn't be able to do this stuff. And now if we're subtracting between two natural logs or any kind of logs, right, that actually means that you're just dividing the things on the inside. So we can actually condense our answer to be this as our final form. And there you go. That is partial fraction decomposition for case 1. So go ahead and pause the video, and then you're going to go ahead and try your OYO question down there below.